Ladies and gentlemen, WeatherBrains episode number 1075 for the 24th of August, 2026. Welcome. This is the pre-show. Magical time of the program where we typically do three things. We share boring personal stories, humorous anecdotes, and from time to time we say some really outrageous things. A little late getting the pre-show started, but thankfully we have no weather issues. Last week we had a great show. We had Jim Ledoux on the show. It was a really good show, but I had active weather. And for those that are new here, I actually am working during this show. So when we have active weather, I have to go tend to that. So it was a really good show to listen to while I was driving around last week. And I do that all the time. I get so busy, I miss things. So I listen, Kim, while I'm driving later in the week. And it's a great listen. It really is. So welcome. How are you?
Doing all right. How are you? Hey, JJ.
How are you guys doing?
JJ.
Great. I think
Yeah, thanks.
JJ's
Good.
doing good.
Okay. Do you have any adjustments behind me or anything?
Look good. You look good. You sound good. All's well. Everything's
Okay,
good.
great.
Trying to figure out what that artwork is behind you back there.
The, this one? This
Yes.
was so when I was growing up, it was a local TV meteorologist. His name was Don Woods in Tulsa, and he always drew what's called Gusty. He was an artist. And so it was a representation usually of what the weather was going to be or something. And in this case, my mom found it at a garage sale and it says fair because that was the weather forecast. And also the state fair was starting. So
Oh,
Wow. That's outstanding. So let's see if James Adelot does that. James has taken over the reins in Tulsa. James, do you have little characters that you draw and hand out to your viewers?
Hey, I do not, but I do have one of those Gusties around here somewhere, and it's in
okay.
color I got from Don. Yeah,
Oh, wow.
that's very
Okay.
cool.
oh
Let
my
me see if I can
gosh.
find that. Hang on a second.
Yeah, go look. If we can have a collection of Gusties, that would be adorable.
I've
Would
got the
love.
And that's
book
a great show
somewhere.
title, Collection of Gusties, but we can't use it
Yeah.
because we're not recording yet. Collection of Gusties. Um,
We'll see if James can
okay.
find it. Oh, and we've got Carrie on too. Yay! Hi,
Hi there. How are y'all?
Carrie. Great. Oh, you sound wonderful. Look great too. Look at this,
Well,
James. Both of our
That's
guests
good
have
because I just
met.
got to my hotel room and you know how that is.
Oh,
Yeah,
yeah. Where are you?
I'm in San Antonio.
Oh, awesome. Are you doing research work or just travel?
I'm going to be at the Texas Floodplain Management Association meeting starting tomorrow. So, yep.
Oh, that's perfect. This could not be more perfect. And I'll ask about this on the show if it's
Mhm.
salient, if it's germane,
Yeah,
but is there going to be a conversation about this event and lessons learned there?
absolutely. Yep.
Okay, if you'd like to, I think it'd be really neat for folks to hear what's going to be on the agenda. If you have any thoughts,
Sure.
and you probably helped put some of that together, I'm guessing.
Yep. Absolutely.
So
Wonderful.
we have a San Antonio representative and we have an Austin representative who just joined us. We now have Troy on the line.
Oh,
Hi,
wonderful.
Troy.
You should recognize Troy, Carrie.
Yeah.
Hell, Carrie, I'm still here trying to figure out the Zoom real quick. So there we go. Hey, Kim. Hey, everybody.
Hey. So I see Rick is here. I know that John Gordon is out this week. Jen, are you? Did you find internet access or Mobile One? Mobile One, come in. Mobile One, come in. Mobile
Mobile
One.
Mobile One is here, and I cleared the rain out just in time, so we're good.
Man, you look good and you sound great. They're clean as a
Thank
whistle.
you.
I mean, this is great.
Yay.
Wow.
Thanks, James.
Amazing.
Okay. Good. All right.
Well,
Well,
whenever
let's
you
get
get
going here.
Okay, we'll get going. We'll talk about it. I'll ask my question with the audio going.
Yeah. Let's hold the good stuff for the real show here. All right. Here we go in 5, 4, 3, 2, 1. Uh-oh. Wait a minute.
3, 2, 1.
Yeah. I was so excited. Let me hang on here.
False start. Number 42. Offense.
Uh,
That is so weird. The little soundboard that I use is not coming through. So let me try that one more time.
Delay of
We can
game.
have the producer. Yeah, we can have the producer add this in later. Let's see. Oh, there it goes. Let's see if you can hear the foghorn. Did y'all hear a foghorn?
Mm-mm.
I didn't.
Nope.
No. All right, hang on. Let me do one more little.
He led 5 more shots to death last night.
Did he?
They took, but you know that you should never choose a set of false teeth from a street display window.
Did y'all hear that?
Yes.
Yes,
Afraid so.
unfortunately.
Okay. It's just you should never choose your false teeth from a street display window because you should never pick your teeth in public. That's the punchline on that.
Oh.
Let me try one. Let me try one more thing here. Hang on. Okay, we're good to go now. It's been a Monday all day today. It's just been a Monday kind of Monday. All right, here we go. Producer JP, I'm sorry. Producer JP, here we go for real in 5, 4, 3, 2, 1.
You're listening to WeatherBrains. They're kind of a big deal.
So says the real Bill Curtis. Hey, this is WeatherBrains, episode number 1075. This is for the 24th of August, 2026. We're getting that close to meteorological fall. Troy, when does the average high in Austin drop under 90 degrees? Let's get a progression here.
Christmas, maybe?
2036, maybe? I don't know. I don't know. Ask Carrie and I both, because it's been another one here in Austin. And I think 105 at Camp Mabry today, Carrie, and I think 103 at Bergstrom. But who the heck's counting?
Woo! Woo!
Unbelievable.
Goodness, we actually had some spots in the northern part of Alabama close to the upper 50s this morning. It was near 60 this morning.
I'm out with that. If y'all are going to insult us, come on, Carrie, let's leave. Come on.
Exactly.
The dew points are down. There's a little hint of fall in the air. It'll get there in maybe January. So,
well, the one thing
other
about
than
it,
that,
James, down here,
yeah,
that's actually saved us. Our dew points have been down in the upper 50s to around 60 the last few days, over the weekend particularly. And I worked EOC for a soccer match on Saturday, and it was interesting because basically the heat index was the ambient air temperature. It really wasn't making that much difference. If that dew point had been higher than that, I think people have been dropping. So,
Yep.
Is that an unsportsmanlike conduct penalty on Mr. Span for the? That's 3 flags up thrown already.
Yeah, I'm sorry. I should not have mentioned that. But I will tell you that there's a little twinge of fall in the air here. All right, let's go down to Mobile One. Jen, where are you? Reporting live tonight.
Thank you, Eagle. I'm coming in from near Pensacola, Florida. I am at Fort Pickens campground, actually, and it was a little bumpy earlier. I sent you all a radar, and I was getting a little nervous. I got very nervous when I actually drove into the campground, and I was talking to the ranger, and I said, "So what is your protocol for warnings and severe weather?" He goes, "Well, we'll give you a 4-hour notice." And I'm like, 4-hour? And he thought I meant like flooding, because if it floods here, I can't get off the island. So I said, "No, what if there's a severe thunderstorm warning or a tornado warning?" And he goes, "You guys are gonna have to fend for yourself." I'm like,
Wow.
Okay, I'm a meteorologist and I have a tornado on the van. I just want to let you know here, I have to have a bigger plan than that. I said, "Can I go to the bathroom?" He goes, "Oh, I guess that would be a good choice." I'm like, okay, that does not make me feel good. So we may have to work on Fort Pickens.
Woo! All right, we'll put you on that project. Wow,
you got that
no,
right.
You're quite when the storm came through Mobile, Jen, it packed a punch. I mean, it was really nasty coming through Mobile, and it actually weakened a little bit by the time it reached you. So
Yeah,
hopefully
that's what
the
made
van
me
was
that's
not.
what made me nervous. I saw what you were doing in Mobile and causing all that havoc. And I was like, I didn't want that coming toward me. So
Yep. Well, looking at things, I see nothing more than what a gentle light rain. So you're in good
yes,
shape.
exactly.
All right, let's go back to Hades here, Oklahoma. Let's go to Rick Smith, our one of our two one of our two hot cars. Rick, how hot was it today in Oklahoma City, Norman?
It
Tell 'em
was
about
100
Chickasha.
and something. That's just
I
the
think
default
100 and
answer.
something. That's your
100
show title.
I think we got 110.
Okay,
I
it
saw
was
110
hold
on the mezzanette.
It was
The
100
Norman
and,
mezzanette.
110.8 in my backyard, so 111. And I think that was the Norman mezzanette site too. Oh, no, at the building, it was the weather center. Anyway, what does it matter? It's 100 and something. So
It mattered in
And that's
Chickasha.
clearly our
There, we've got
now,
several
James
good-
has got some cool trivia about heat in Oklahoma. I know he does.
well, James, how go?
Just read
Let's
the
hear it.
NWS
Let's
chat
hear it.
post that you just did.
Oh, okay. No, so Tulsa, we had showers this morning and the clouds stayed over. So we were in the low to mid 80s in the metro area all day. And about 20 miles west of downtown Tulsa, we saw upper 90s. And what I put in I don't have a long enough table of mesonet high temps, but the 115-degree ambient temp in Chickasha today, I believe, is the hottest since Ponca City had a 116 back in 1996. So this is
Ouch.
stupidly anomalous.
Whew, this is nasty. This is just
But it was
nasty.
in the 80s here, so
All right. Well, let's see. Kim, before we go into spontaneous combustion, would you please bring in and introduce our guest? It's going to be a good show tonight.
Yes, I am so excited to talk with our guests. And actually, we might bring Fort Pickens back into this because being prepared in a campground is a really salient point for what we're going to be talking about tonight. So, people who frequently listen to our show probably heard us just after the 4th of July. We had a sort of debrief. I think a little bit about what had happened in the event, but it really became a discussion of how much anxiety I think we all still have about have things been addressed, have things been fixed, and just among that conversation with that group, I thought it would be really wonderful to bring in people who knew a lot about this to talk about the event and what happened from different perspectives and to talk about where have we come over the last year? What have we learned? What lessons are being learned? And where can we even see maybe bright spots in our future? What could be coming down the pipe? And that comes from two really, really talented scientists. We are so extremely honored, humbled to have you both with us tonight. First, we have Dr. J.J. Gurley. He is a senior research hydrometeorologist at NOAA's National Severe Storms Laboratory. And he manages an interdisciplinary team there that's developing the FLASH product, something you may have heard a bit about. It's a flash flood forecasting product, and JJ can provide an overview of that to us. And he has a long history of decorated research. He's won the Department of Commerce bronze and 2 silver medal awards, the AMS Journal of Hydrometeorology Editors Award, a NASA Group Achievement and Robert H. Goddard Team Awards for contributions to algorithms comprising global precipitation measurement mission, and author of over 160 peer-reviewed journal articles and a radar hydrology textbook. Welcome very much to the show, JJ.
Thank you.
It's wonderful to have you. And Carrie, I'm going to give your introduction and bring you in when we get to the social science piece of this. But everyone in the audience know that our second guest tonight is Dr. Carrie Stevens at the University of Texas, Austin, reporting tonight from San Antonio, we've learned. So we have our San Antonio correspondent, and we'll get into your background and what makes you so great to plug in and when we get to the social science piece of this. And first, JJ, I'm wondering if you can refresh the memories of our audience about the nature of the event. You and colleagues at NSSL recently wrote 2 BAMS articles where you were talking about this event. You provided an overview of what were the extant circumstances for what made this event, what it became. And you also are the lead author on a paper with that team looking at the one on forecast system plugged in with Flash and how that predictive capacity could handle an event like this. So welcome to the show. I understand you might have some prepared things to walk through with us to get into some of the event. Is that right?
Yes, I can just discuss it in brief right now and kind of give an overview and then jump in. If we want to see a few graphics, we can do it that way as well.
That'd be absolutely wonderful. Although I almost forgot, almost got ahead of my own skis. I think we haven't had you on the show before, if I'm remembering correctly. So let's get to know you just a little bit. Tell us a little bit about your background and what brought you into the hydrology part of meteorology.
Okay, yeah, good question. Well, like many guests, I presume that you've had, I had an impactful event when I was a child. In my case, I grew up in Oklahoma, in Northeast Oklahoma, Tulsa area, just out east in Broken Arrow. So I see a few people cheering. Yeah, I was in a tornado in Broken Arrow when I was about a year old, and I think meteorology found me as a result. So I've wanted to be a meteorologist as long as I can remember, and can remember running home to catch the news broadcast to see the weather and skipping the neighborhood football game and things like that. So probably a similar story that you've heard from a lot of folks. And then I think when I first saw a flooding event, that was 1984 in the Memorial Day floods, and that's when I really saw how widespread and impactful it could be. And even in my own neighborhood, there was a section of our neighborhood that was completely cut off, that was on an island for a while. And just to see the waterways just fill up and become really impactful as a child, that had an impact on me. And so lo and behold, I made it to the University of Oklahoma in meteorology, and went through my undergraduate degree there. and and then at that time, I think Rick could probably speak more to this perhaps, but I remember that there was a hiring freeze back in those days, and there was a lot of us, 1996, who graduated, and we didn't have anywhere to work because the private sector wasn't very fully developed at that time yet. And so a lot of us were kind of scrambling. I can remember classmates working for Kinko's and pet shops and different things like that. And so I had knocked on the door of a colleague of mine. Ken Howard was his name, at the National Severe Storms Lab. And in those days, we had a double wide trailer out next to an old radar. And I knocked on the door, and he interviewed me on the spot. And that was in 1994, and hired me. So I started working at National Severe Storms Lab back when we were on the North Base. And then a research opportunity came open for me, and so that's when I decided to get into graduate school and pursue that route. And then the question about how did I get into hydrometeorology is I really had a background in radar, and it was still kind of new back. I mean, that was in the mid '90s, right? And so it wasn't like it was everywhere all the time. Um, and it occurred to me that one of the applications that could really make an impact on society and beyond would be the rainfall aspects of it. Because I had taken some hydrology classes, and we learned about this one rain gauge in this big basin, and talking about basin average precipitation. I'm like, why would we do that? Look at this radar. You can see all the details and the gradients and movement, and it just doesn't make sense to me. And so that probably led to my passion to go down more the hydrometeorology route, and so I got my PhD in civil as a result. And yeah, I've been working somewhat continuously for the National Severe Storms Lab since then, since 1994. So.
That is excellent. What a background, and what a perfect background, I think, to bring to an event like this. And with that, would you like to kickstart us? Talk a little bit about what brought you all to study this event. I think in particular, what were you looking for? And then feel free to share all those insights, what you guys learned when you did this exploration.
Sure. So I imagine, like many of you listening and here on the panel, we're probably pretty shocked at Fourth of July weekend, and maybe you were, on vacation, or like me, and we're doing things and then reading this terrible news. And so I came back, and we have a few of these systems that we've developed that have become operational. Many are familiar with the multi-radar, multi-sensor system known as MRMS. And And so with that, it runs operationally. And one of the things we wanted to do was to look at how it performed during the event. So that was kind of step one, was to see how things were behaving during the event. So that's the first thing I did, was looking at the rainfall estimates, and we have this really nice website. Forecasters can access it to basically, you know, determine how the radar-based algorithms estimated the rainfall, and it looked pretty good to me. And then I went onto the system that the project that I led continue to lead for a number of years, which is called Flash. So it basically takes the radar estimated rainfall, puts it into a hydrologic context, and that provides forecasters a lot of guidance when they've built up a lot of local experience, a lot of training materials built around it, and so they use that a lot to basically diagnose when you're going to have a really high flow situation. So I looked at those results as well, and they were pretty darn good. I have to admit, in my career, when I first saw radar generated rainfall maps, I never thought I would see them get to this stage where they were literally about as accurate as you can get with the rain gauge. If you consider the errors that you get in rain gauges with wind and splash out and things like that, that really the radar estimates for this extreme event too were there. So I knew there was really a compelling story to be told, but this was really on the back end of it. It's like we need to tell all the chapters leading up to this. This is almost kind of the end of the story. And so that's when I gathered some of my colleagues at NSSL who have a lot better expertise, and looking at the microphysics of the heavy rainfall, looking at the synoptic setup, and zooming down into the mesoscale and storm scale, and really zooming in, and what got us to this point. And that's where we decided that we would yeah, get together and produce a study for that. And then in doing so, I was working with the branch of folks that I work with who have been developing the Warn on Forecast system, which gives you a forecast 0 to 6 hours in advance. So it's very much operating at the scales at which this event would apply for sure. And so they ran a 1 kilometer, like an experimental version of it, and I looked at the results. I'm like, those look pretty decent, but let's put it into the model and see what the model would do. So, I basically tricked the model into thinking that it was the MRMS inputs. But in the future, so this is going to be able to add lead time, because the MRMS rainfall will give you what's basically occurring in the air at the moment, or what has just occurred, and then the flash system will give you the hydrologic response to that. But I'm like, if we can give forecast rainfall to this, then we're just adding on lead time to that. And then I saw those results, and I'm like, oh boy, this is another compelling story. So that's when we decided to kind of break apart. We initially were thinking to do a part one, part two kind of study, and then one of the reviewers who made himself known to us, so that happens sometimes in a BAMS review. One of our colleagues, and basically said, why don't we call them companion papers, because they can stand alone on their own, and if it's a part one, part two, then it could shy some readers away from it, to think, do I have to go through this slog to get through both of these? And so that's why we did the companion articles. And why don't I just take a brief stop right there, and then if anybody has any questions, I could share a screen and jump into that part of it.
I think we're all excited to see you jump into this analysis. Lots of very excited nods. Go for it, JJ.
Okay, great. So I am sharing, and let me see. Okay, I can see everybody, and I'm give it a thumbs up if you can see my screen. I'm not a Zoom expert. Lots of thumbs up. That's good. Okay, so this slide kind of summarizes really the meteorological setup leading up to it. And this was most of the work that was done by my colleague Tom Galarno at NSSL. And I just want to state up front that he's really an expert at discovering these clues, and I'm not sure if it would have been possible by anyone, much less him or anyone, to know these little details in advance, that they're really cryptic and buried in there. And in particular, if we're looking, like in the Western Caribbean, there was a tropical storm Barry that was sitting there, and Tom needed to do this kind of air parcel back trajectory analysis to see where the moisture came from. There were some clues on the Del Rio sounding that evening that we had some really anomalously high moisture throughout the depth of the column. And so I think the integrated water vapor was number 4 recorded at Del Rio. So there was definitely some high moisture content. And so Tom basically tracked the source of that at low levels, and it was Barry that was out there way in the Western Caribbean, coming all the way up through Mexico into South Texas. And then secondly, he found there was a pretty significant impact by tropical cyclone Flossie, which was in the Pacific. So this created more mid and high level moisture that made it all the way around a ridge and then kind of came in through the western side of Texas through Mexico. And so those were the sources of creating a really unusual moisture setting, which, as you know, those that live in South Texas say, well, this isn't too terribly unusual. So now I leads us to the third ingredient. So over the mountains, the Sierra Madres and in Mexico, and then leading, going all the way up into North America, into the United States, that you get a lot of convection that develops there over on almost a daily basis, and that's part of the monsoon, North American monsoon. And occasionally, these big MCSs, mesoscale convective system, will then spin off what's called an MCV, or mesoscale convective vortex. And they happen, they've been studied more like in Colorado and New Mexico. And so you'll get this little vortex that'll kind of meander over in the plains. And that's something in an environment with a lot of deep moisture really needs to be monitored carefully. And the reason for that is it increases the wind shear, and that's what it did, and there was a little boundary that set up as well, and so really with that increased vertical wind shear, is it enabled that rainfall to get really an extra kick whenever it was there right over the basin, the Guadalupe River basin, and it turns out that it created a supercell. So this was not your run-of-the-mill kind of heavy rainer that just kind of sticks into place. It actually had supercellular characteristics. It wasn't a tornado or anything, but it had a lot of shear. You could see it in the Doppler velocities, and so that also enhanced the ability for it to create extreme rainfall rates, which it did. So a little over 10 inches of rain it accumulated. 9 of that fell in 3 hours. So this is really an extreme amount of rainfall. And then if we move more into the hydrology aspect, that we had and I'll leave this for the rest of the folks to discuss, because we decided to keep this focus on the hydrometeorology and then the hydrologic forecast. And if you get into the social science, we're like, wow, as much as that would, kind of tell the full complete story, that it's just going to add so much more to this study that I don't think that we can do really in-house. So we kind of left that out a little bit, but there were a lot of factors that combined that kind of caused this to be really a disaster. Being a holiday weekend, it was at night. It was nocturnal. There were issues with, as I'm sure we'll learn a little bit more later, about some of the evacuation plans that might have been lacking, and communication, and so on. For us, I say as us, as a community here, that this was kind of the big deadly flash flood of our generation, really, because the last big one was Big Thompson Canyon, that was all the way back in 1976, that killed 156 people. So this was the biggest one since that. Before I go to the next one, I'll just want to point out, when I show that rainfall over the Guadalupe River basin, that rainfall is almost wholly concentrated within that basin. And that's, if you think about it, if I just shifted it, like 10 kilometers to the south or even to the east a little bit, then you break up that water and put it into different basins. And so if that had happened, we wouldn't be here. You'd have somebody else who was much more interesting talking about something else. But that's a really unique aspect, is it was just so concentrated right in that basin that really created some big issues with that.
What are
So yeah,
influence
go
of
ahead.
factors? Oh, sorry, just um, the confluence of all those factors is so remarkable. Is that confluence something that I don't know if you guys did a formal analysis, but is that kind of confluence common, especially for flash flood producers? Is that sort of a kind of confluence you typically see that creates something like this?
And not so much. In fact, it's a question that we really beat around a lot. Is there something about the terrain or the slope, or there was a strong low level jet that's kind of coming in from the east southeast, and it's moving up slope against that terrain. Or like, was there an impact that kept it stuck to the terrain? Because you do see that with some storms, and if you can see this in the animation, you can see that supercell right there, is it just gets stuck there for a while. And I know that Tom Gallarno looked at this in a little more detail, and he ran some model simulations with the WRF ARW, and he ran it with terrain and then also with flat terrain. And when he ran it with flat terrain, the storm actually continued to move off to the north and the northwest. So it's something that we should probably look at in a lot more detail. We just kind of saw the results with and without terrain, and it made a big influence. But what were the real driving factors and the underlying physics behind that still remain to be explored.
Thank you. Sorry, feel free to continue.
Yeah, so this was the big rain event. So just showing an animation of kind of what that looked like in the overnight hours. And then if I'm looking at the rainfall that we generated with the multi-radar, multi-sensor system that's shown here, and there are two different versions that I'm showing. In the upper left panel was this slightly older version that we were running in real time on our system at NSSL. Some forecasters can access that as well. And we kind of have to stage our latest versions on our local hardware. And then whenever the Weather Service is preparing to onboard something, then they do it at a little bit later date when they do, in upgrade the version. And so the actual the version 12.3 is the one on the bottom, and that was the latest greatest one that was running. And so if you look at the scatter plot and the statistics and everything on the right, I'm like, it's hard to improve upon that. I mean, it really is. And so our takeaway there was that, the errors in the radar-based rainfall estimates are similar to, or maybe even smaller than the rain gauge values themselves, and that's the first time I've really been able to say that. And that's with an extreme event. So that was pretty compelling part of the story to me. And then once you move on to the hydrology, so if the radar's out to lunch, then this aspect of the project's really not even going to be possible. So this is where we take the rainfall estimates and put it into a hydrologic model, which is then going to forecast the hydrologic response. And so this is showing it on the North Fork of the Guadalupe. So this is a gauged the north part of the basin. And Camp Mystic, we'll get to that in a moment, is on the South Fork, which is not gauged. And so in those two, on the whole entire South Fork, we don't know what the true, flow was there. But we do at the North Fork, and then also on the below the confluence of the north and the south, and that's what's shown on the right. And it's kind of hard to see, but those black dots actually turned to X's at one point in that time series, and that's because the gauge was blown out. And those were estimated flows where they had to come back and do some analysis and look at high water marks and kind of back those out, so to speak. And then what I'm showing in the two curves that look a little smoother on there, those are the results from the hydrologic model that are conditioned on those two different gridded rainfall inputs that went into it. And again, this is really this is how the model ran in real time, and I didn't tweak parameters or do anything. I mean, this is how it ran out of the box in real time and live, and I was pretty darn shocked when I saw these results, I have to admit. I didn't think it would be this good. We try to get things kind of in the ballpark. This is really meant as a tool to tell forecasters, like, should I issue a flash flood warning or not? It's really not really meant to go after peak flows like it's doing here, but it succeeded pretty well in that, as you can see, but with the full admission that this is a diagnostic tool. And what I mean by that is it's telling me the response when the rain's basically hitting the ground, or it's already hit the ground. And so the question that kind of led us to the next portion of the study is, could there have been more lead time? And even before I go there, I do want to mention that there was a flash flood watch that had already been issued well before this event, and the flash flood warning was very timely with this event. And so, really, what we're trying to communicate is more information that's in this so-called watch to warning gap. Do we see things ramping up in a way and are targeting on a specific area that could be used by the local meteorologists and emergency managers and so on to maybe up the ante just a little bit more before the warning comes out. So that's kind of our target in here. And to gain a little bit of familiarity, and I was describing these before, that this is the North Fork on the north side of the basin, big shocker there, and there's a stream gauge here, and then below the confluence. And if you look at the rainfall that's shown in the background, you can see that the really, really bad stuff is on the South Fork. That's where the heaviest rainfall amounts, and that's where Camp Mystic is. And the little inlet panel, you can see I've outlined Camp Mystic, and there are actually two creeks that come in. There's the main South Fork of the Guadalupe. There's also this little Cypress Creek that kind of sneaks in from the south. That's going to become a player at one point in this. And also wanted to mention, whenever we looked at our simulated data, I don't go into it too much in these plots, but we found that there was actually 3 times more water that was coming off the South Fork of the basin compared to the North Fork. And that catchment has about half the size. So this was really an extreme amount for the South Fork. For the North Fork, it actually wasn't even a record flow. On the North Fork, it was below the record flood stage that happened in 1932. So, but below the confluence, which I'm showing here, it was a record, and that's because of the South Fork contribution, without a doubt. So now, to describe this plot, I'm showing all of these kind of horizontal lines that are giving you the different flood stages on here, and then in the black ones are kind of our observed data. So you have your gauge flows, and then the MRMS simulated in the smoother black curve, and then all the blue lines. What are these? These are whenever I've provided the Warn forecast different what we call ensemble members. So you get 18 different members that come from this, and we put that into the model, and then let that serve, as the forcing at the future time step. So we have estimated rainfall from MRMS leading up to whenever we initialize the model, and then we forecast using, the actual precipitation or the forecast precipitation from Warn forecast system. This particular initialization is at 0 to 2 UTC. So locally, that's at 9 o'clock at night on a Friday night. And I put that in context because some of the stories I heard was, we thought it might rain tomorrow, and a lot of people went to bed, and so this would be the kind of information which would be potentially available before you go to bed, because it's Friday night, holiday weekend, 9 o'clock, probably not a bit in bed yet. And if you had, in this case, I had over half of the members that were over a moderate flood stage. So, and this is, a big target at this point, because we're looking at the whole Guadalupe River basin. And so, would have potentially provided some information in and of itself at this point. And then we decided to really challenge the situation, and let's zoom in now really to the Camp Mystic issue. And so that's what I'm showing here. This is on that tiny little catchment Cypress Creek. Okay, so now if you think about getting things right, getting your rainfall observed right, getting your forecast rainfall right, I had a big target, which was the whole river basin. Now I'm zoomed into the bullseye. So this is really hard to get this one right. And this is the same 02 UTC initialization from the model. And you can see once again, I've got over half the members that are predicting, a moderate flood stage on this tiny, tiny little creek. So, and these rainfall amounts on here were just, incredible how much it rained at this particular location. Um, and so we did this for several of the monitoring points on the South Fork and Cypress Creek, and then what I'm showing is kind of a timeline moving left to right, showing the number of ensemble members that have kind of exceeded their threshold. And so you can see that it was about that 02 UTC initialization when things really bumped up. You can see it go kind of from orange to red, and then it pretty much stayed there. There's a little lull around 5 or 6 UTC, but it's giving a lot of information that, hey, this could be really bad pretty early on. And we also looked at the high resolution rapid refresh, and it had some early signals. It's deterministic, so you don't get the probabilistic answers, but it had really early signals that then went away. So what it did is it moved the storms that were initially in the basin and then kind of moved them up to the north, and they never really came back. So that was kind of the takeaway there, that the warning forecast maintained them and kept them in the right spot. And so to really summarize is that, to forecast at this kind of level is that you're really sensitive to errors in the location of that rainfall. So, if somebody gets a supercell forecast correct and they're maybe one county off or something like that, I'm like, did it go in the right basin? Because it's got to flow in the right direction, the right area in order for this to be useful. And so the location is absolutely essential for these kinds of forecasts. And we saw the Warren forecast system get that right for this particular case. And then we saw as time progressed, as I added later and later initializations, you would hope it would get better. You got better initial conditions, better data assimilation going in. And we saw that it did start ramping up the forecast. And so in the end, we computed, that we had about 5 to 7 hours of lead time, depending on how you count, how many ensemble members that you would have counted. So that's a pretty good amount. And so, could it have prompted a response capable of mitigating the fatalities? In the future, I would hope so. I mean, for this particular event, this is probably going to be the good segue to the social science. I don't know the answer if that would have been the case or not, given the situation there. And then, admit wholeheartedly that this was really a first case. We've looked at some more cases since this event in the last year. And it worked pretty well. So we're excited to continue this development, and we do have a project that's really just going to be starting in September, about a 2-year project where we're going to be able to stand this up and get it ready for an operational posture. So I think I'll just pause with that and see if we have any questions.
That is remarkable. There are a lot of comments in our little group chat here about how incredibly impressed we all are. Would love to open up. Are there any comments or questions our panelists have on this piece? Go ahead, James.
I'm kind of overwhelmed, really, at how good this thing performed on such an anomalous event. And I know Troy has mentioned before, talking about just even the soil structure contributed to this as well.
That's right. I mean, we were, I have to say, I was pretty shocked on several aspects of it. From the radar rainfall estimation is very difficult to get that right, and the hydrologic forecasts, and then the Warren forecast. They were all pretty shocking. And so we felt that we had a pretty big story that needed to be shared, and I like being in what we call the honeymoon phase of a project, because I've been here before with Flash system, and well, let's just say I'm going to have different stages coming at me in the future.
So when does this move from experimental to operational? Let's get real here.
Yeah, that's the next phase that we're looking at. We have a project funding for 2 years. So that's our goal, is to stand it up and get it running with the Warning Forecast system. It'll need to be the 3 kilometer Warning Forecast system, so it won't get as the benefit that the 1 kilometer did. And we've conducted a number of studies that says that 1 kilometer helps quite a bit, and getting some of these details right, and even going getting the rotation right with supercells and things like that as well. So we look forward to getting the 1 kilometer, getting it at a better posture for operational use. So, but that's our target. And we also have some emulator development that's exciting, some things that could be used to kind of mimic our physics-based system that can run much more quickly, and that'll make life a lot easier, on and not so expensive to run it too, because this is all you pay for a lot of the cloud computing, and that's a real issue that we need to consider.
Yeah, it's really interesting to hear about this in light of the transition Warn Forecast as a system is facing getting into operations, and having it run routinely, and it does take a lot of compute resourcing. So I'll be really excited to see where this all lands, and to follow this as you go through your continued operations over the next couple of years. What a wonderful and promising success story, though, and we're very grateful that you came to share this with us. Are there other questions or comments from the panel on this piece? And of course, we can come back around. I think we'll have a great integrated conversation after we talk with Carrie too. All right.
I just wanted to make a quick comment
Please go ahead, Carrie.
That the resolution is going to be really important moving forward. And I know that costs a lot more compute resources, but I have spent a lot of time in this area, and things like Cypress Creek, various little tributaries, there are so many in this area that a lot of people make the assumption that the main North Fork or South Fork is what's causing all the action. And it is part of the action, but it by no means accounts for all these other areas like Cypress Creek, and they are all up and down in this area. So glad that you could actually capture the difference there. I think that's really important in this area.
Yeah, and thanks. I forgot to tell a main part of the story was that we had found, when we simulated the flows on Cypress Creek, that the peak occurred almost simultaneously with the peak on the South Fork. So you've got both of them arriving right at the same time. And our model is actually a little bit simplified in the way that it routes water. And so and it doesn't account for this, but there were without a doubt backwater effects where it was basically Cypress Creek running into an already flooded situation, and that causes it to back up. And that's right in the camp. So that there's no doubt in my mind that Cypress Creek was a big player, and it probably complicated some of the ways out, would be my guess. I haven't been there and know that for sure, but I'm guessing that created some complications that weren't anticipated from just having the main stem of the South Fork flood.
That's a great point, because a number of people that I've talked to that said, well, the water came from the other direction. I didn't even know there was water that could come from the direction that it came from. So yeah, their routes were cut off. Some of them were flooded from not a primary river, but from these various creeks. And a lot of kind of eyes were opened about the fact that there's water all over the place here. Usually dry creeks, by the way, but when they flow, woo, they can be powerful.
Yeah, well, and not to cut to the chase here, I think our audience can probably tell you have a lot of familiarity with Texas, Dr. Stevens. And at this point, then I'm going to give our quick introduction to you, and let's get at it, because you clearly have a lot to speak to about this. So, audience, our next guest is our social science half of the program here, Dr. Carrie Stevens. She's the George Christian Centennial Professor of Organizational Communication Technology, a UT Austin Distinguished Teaching Professor, co-director of the Technology and Information Policy Institute at the Moody College of Communication at the University of Texas at Austin. Her expertise includes organizational communication, and I think, Carrie, we'll talk a little bit about what that is in a minute, because that's a really key part of this. Mobile technologies, artificial intelligence, crisis and disaster communication, infrastructure communication, and health communication. She's an International Communication Association Fellow and has authored over 150 peer-reviewed publications and 5 academic books, and has a large and sustained portfolio of work sponsored by NSF, but also, importantly, to this conversation, the state of Texas, including from the Texas Water Development Board, the Texas General Land Office, and the Texas Department of Transportation. And I am so excited to welcome you to the show. Thank you for being with us. I think I'd love for the audience to get to know you as a scholar a little bit first. Tell us about your area, what organizational communication has to do with disaster studies too, and also what brought you to flooding, because it's important for folks to know the stuff you've been funded to do is really looking at how do we improve flood communication.
Yeah, exactly. So I'm a native Texan and I'm a flood survivor. And so I grew up on the Clear Fork of the Brazos River, which is about 90 miles west of Fort Worth, Texas. The kind of place that you don't drive through there unless you need to go there. Very rural community. So I've done a lot of work with rural Texas. And organizational communication, my undergrad degree is in biochemistry from Texas A&M. And I spent a decade working as a chemist and realized that a lot of the really challenging questions that I had to ask had to do with why people didn't do what I thought they should do. Like the logical, rational behavior was just not what I was seeing. And so I went back to school at 30 to become a social and behavioral scientist. And then I got hooked and I stayed. And so organizational communication really drew me in because it does take a look at the role of coordination, the role of collaboration, the role that organizations can play in trying to help people become better prepared. And I've done a lot of work with crisis and risk. And for the last over a decade, I've done extensive work in flood communication. And I found myself getting started with that during Hurricane Harvey when that hit in 2017. Coastal flooding is just very, very different than what you find from flash flooding. And so I've now looked at a lot of different kinds of flooding, the challenges we have with communicating about warnings and alerts. I'm sitting on a couple of the different integrated warning teams in Central Texas, and just really enjoying the conversations that people are having around the fact that we can't just assume that the gauges are going to work and not get blown down river whenever we have these ferocious events. Our technologies, we need them. We've got to have them out there, but they're part of the picture. And the people are really another part of the picture. So what I've done with this particular flood has been my team got a National Science Foundation grant. And originally we said we want to know about why some people evacuated and some people didn't. Well, we've learned a whole lot about that. And I would say that my understanding of that area is a lot stronger now. I'll actually leave San Antonio and I'll go back to Kerrville and spend another couple of days in Comfort, Kendall County, all around in that area, because unfortunately they got hit again this year. And as a matter of fact, the amount of damage in the area is more this year than it was last year. Now, loss of life, very tragic last year, much more comprehensive there. But this year, a lot of damage in the area too.
I would love to hear your retrospective too and thoughts. I'm sure you had so much you were thinking about, you and JJ both, as the floods took place this year. I think let's come to that in a minute. And first, I'd love to hear your rundown. What was it that you learned from this event? And talk a little bit too about what makes for a successful evacuation from a flood. Has that been contemplated? And what does it take to make something like that even work? And then what did you learn in this event?
Well, I'd say the biggest thing we learned is that you got to ask a lot more questions than just evacuation. And, I think that in most situations, evacuation didn't happen in 2026. I mean, 2025. In 2026, we had a lot more people who were able to evacuate because it was a very different kind of an event. But if we go back to 2025, the night, the lack of the fact that that area hadn't had a lot of flooding that was quite like that in the recent past made a tremendous difference. And one of the things I want to point out, JJ mentioned that there was 9 inches of rain in one area, I want to say in 3 hours. Well, one of the interesting quotes that I have from multiple people that we've interviewed in this study is people talk about a normal flood all the time. And they're like, oh, yeah, I get a warning. It says 2 to 4 inches. Yeah, that's a normal flood for us. People have normalized and they know what to expect when they get some of these warnings and alerts. And it's based on their prior experience and their past history. A lot of that I think is very good and it actually does prepare people. But where the gap is that we're seeing in people who are local to an area is they just haven't anticipated what's possible because almost everything they're thinking about is what they've seen before, what their families have seen before. I mean, I'll give you a classic example. If you look at the map that JJ showed, way up high in Mountain Home, that's the name of one of the towns, there are people on the bottom end of the Guadalupe down in Comfort, Texas, who have friends in Mountain Home. Friends in Mountain Home call them and say, you're going to have water in 6 hours, y'all get ready. They know the river. They know the way it has historically worked. And there's a lot of value in that local knowledge, but it also limits them in terms of thinking about what's possible. And so I think that a lot of people just didn't think this was possible. And a lot of people didn't know that they were at risk at all. They had no idea. I'll give you another example. One person said that they woke up and they don't live anywhere close to the river. The river, they can't even see it from their house. It's a long ways away. They put their feet down in the middle of the night because they heard lightning and the floor was wet. Well, they thought their water heater had overflowed and they thought it was a water leak in the house. They never even imagined it was the river. So imagine, people who have no clue they're at risk, all of a sudden being in the middle of a flood. The other thing I think that we've learned is the absolute most vulnerable group of people here are people who are not local. They do not have a clue what is going on. Many of them have gone for vacation. I've now gotten to talk to short-term rental owners, RV parks, and essentially everybody's described the same thing. People are coming from major metropolitan areas. They've rented a place or they're pulling their RV. They drive in at night, exhausted from a week of work, ready to just relax or party or whatever they want to do. And the last thing in the world they're doing is trying to figure out if the weather's bad. They just want to start having fun and relax and chill. And so they're highly vulnerable because of the state that they're in. And then they don't know the roads. And I don't know if any of y'all have driven that area very much, but I have driven a lot now. As a matter of fact, this year I was driving 5 days before the flood hit this year. And I did a lot of video related work. And there are so many low water crossings and so many road may flood signs. They're literally everywhere in that area. So somebody who's not local, they're absolutely not going to know. So back to your question, Kim, about evacuation. Some of this is sometimes we don't want to evacuate people from some of those areas because they're just going to drive right into water. And we all know that that historically is the number one cause of death, is driving through flooded roads.
Absolutely. And I think it's something that when I talk with forecasters who look at this event and feel like they mourn, I think it's very natural after catastrophes for our field to feel a sense of personal responsibility and ownership. It's
Yes.
almost on us in the
Yes.
social sciences to help unpack it and say, here's what you were up against from the perspective of the decision maker and what they would have needed to have in their pocket. And it's not just the radar. They need to have all of this situated knowledge to navigate a decision space. It's a whole different endeavor. And so
Yes.
I'm curious, you have been part of the integrated warning team meetings
Mhm.
that have been hosted by the Austin San Antonio
Mhm.
Forecast Office. They've gone to different parts of their area, but including this one. And there has been conversation. I think this year they sort of made it a year of reckoning with this flood and
Mhm.
thinking about moving forward. And Troy's part of that
Mhm.
IWT, and he can weigh in on this as well. But I'm wondering if you can talk a little bit about what were they wrestling with in the group that
Mhm.
comprises individuals from emergency management
Yeah.
through the weather service and broadcast and everyone trying to figure out how to work together
Yeah.
and think about this message of, can we do something different with flood messaging, and what would it take to do something different? What were they
Yeah.
contemplating?
You really said it well there, Kim. I hear a lot of angst in people's voices. They really feel like they should have done more. Well, I think that a lot of this has to do with human decisions are just really complex and they're very varied. And essentially, the instructions that we give people, they depend on where you are on the river. They depend on which watershed gets the most water. It even goes so far as there's one person who I interviewed and he showed me on a map. He said, if we get water here, and he pointed to one point on the map, he said, I know that I have 15 minutes before it's up to here in my property. But if the water falls literally a quarter mile over, I'm fine. Like they know it to that level. And so I think that a lot of people have felt a lot of guilt. And we can do the best we possibly can. There are certainly some areas we can improve on, but this is a very, very complicated problem. And a lot of it has to do with humans and the way that we have normalized floods in our areas, the way that we make decisions in the moment, and the fact that many people have turned alerts off. And y'all, I'll tell you the other thing that's has me very concerned, and that is we have a lot of people in that part of Texas that are hard of hearing. And I've interviewed many people who take their hearing aids out at night. How are they going to hear those alerts and how are they going to hear sirens? Now there are ways that if you think ahead and you have, vibrating alerts, there are some ways, but there's a lot of people in very different circumstances that we're going to need to be thinking about. I would say one of the most encouraging things I've heard in the integrated warning team work is that everybody is talking about how can we get people to realize that a watch doesn't just mean something to ignore. And so we really need to use this. I love the idea that some people are talking about a ready, set, go mentality. Like we need to be doing something during the watch time frame. And right now we are not finding that people are paying attention and viewing a watch at all, like something where they need to be actively involved. And so I think that is one area where we have a real opportunity to maybe change that messaging to really get people to start thinking about, y'all, this is more than just conditions could be ready. This is, do you have a plan in place? Do you know what you're doing? And then the other thing that I think a lot of people have been talking about is how do we make preparedness more fun? I know that that sounds really nerdy, but y'all, if I had to do anything, it's like, how do we make it fun instead of drudgery? Um, I would love for people to go on a scavenger hunt around their houses. Walk in every direction, find all the different tributaries, go pick up rocks, do whatever you want to do, go look at birds, but realize what is around you. Because when you're new to an area, you're also highly vulnerable. You just don't know your roads. You don't know where water's going to flow. And by the way, this advice also works for fire. And I would say that the number one thing that people are telling me is now, by the way, I'm going back to do a lot of second round of interviews this year after these floods. Last year, though, people were telling me that their new highest concern was actually fire after last year's floods. And so this area is going to have to deal with both. The instructions are a little different, but people need to be hyper aware of their areas. And right now, a lot of people are not. And so I want to make that fun instead of, just telling people you got to be prepared. No, let's have them do something and then walk them through something that's an enjoyable process.
I love all of this and the idea of having preparedness be fun. Absolutely feels to me. Make it more fun. Let's find some way. Something that I think was a constant, drumbeat with this event too was outside of the individual level of decision making. There were those public safety officials who were supposedly responsible in some way for trying at least a public notification or trying to tap what you were talking about. There was sort of an informal warning system, a chain where people would talk to each other and give insight down the river, and that there'd been this some level of adaptation that had gone on that failed in some respect in this event. So I'm wondering if you can comment on, were there lessons learned? Because like Texas had a whole reckoning. There were hearings. There was public policy debate. They examined very thoroughly what is our public safety infrastructure, and is it up to task? What was learned in that that should be part of this conversation?
Oh, absolutely. I think, some of the bigger things are that the state passed some funding and some bills that required some of these areas to put in sirens. They also are putting in more gauges. And a lot of these communities are also talking about how do we communicate with the public in public facing dashboards. And so I have a lot of familiarity with some of the work that the Upper Guadalupe River Authority has done. And they now have a public facing dashboard, and they go out and talk to everybody about, do you want to understand what the river's doing right now when there's rainfall? Check out this tool that we've developed. And so we're seeing a lot more of these communities take an active role in educating their populations about what's available, what's out there, a lot more conversations about local alerting systems. And then the sirens are starting to be implemented. Now in Kerr County, I think I'm right about that. In Kerr County, they've actually, they installed the sirens first, faster than a lot of the other counties. Now, some other counties do have sirens in. Some of them are also for fire predominantly and not flood. But Kerr County had sirens installed when this last round of floods happened, and they were activated this year with success. And so it's rare that you get an actual test of a new implementation within a year, but within a year and 2 weeks, they got a test of their system. And so a lot has happened in this area in a very short period of time. I think it's pretty impressive that they have realized the seriousness of this. And I think they're taking public safety very, very seriously now.
Carrie, this is just completely fascinating. Kim and I have looked at this super superficially and done a couple of presentations on it and looking at some of this work. And the siren thing is interesting. I know those of us that live in more tornado prone areas have our opinions with sirens, and I'm not gonna talk bad about sirens that they're putting in. I'm assuming there'll be some type of public education campaign that goes along with that. And I mean, have you heard? Are you hearing that?
Yeah.
Yeah.
So I am, and I want to go ahead and share with y'all right fast this is what I usually show to people is this area is flash flood alley, but this area also has tornadoes in it. And so that is actually my biggest concern. And what I'm seeing talking with this communities right now is they've mandated these flood warning systems, but people don't necessarily know what action to do when a siren goes off because it depends on where they're located and what the siren is trying to tell them. So we have to have public education along with our sirens because we have this situation going on. And then the added complication, I would say, is that in a lot of these communities, the local fire stations also have sirens that are going off on a regular basis. And everybody assumes that you can actually hear what the siren says if you program words. It sounds like Charlie Brown, rah, 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 rah. And then you add storms and lightning and everything, yet you just really can't hear a verbal set of instructions. And the decibel level really varies a lot in with what you're actually hearing, depending on what the weather is as well. So sirens, I think, can be helpful. However, we have a long way to go in terms of understanding how to educate the public and help them know what to do when they hear these sirens. Because if there were a way that we could tell people exactly where they're located, what to do, we could give them good instructions.
Yeah.
But we can't do that. And I think we're a ways away from that hyper local and individualized type of a response.
Right. And the sirens aren't completely new. There were siren
No.
systems in place. Comfort.
Yeah.
Comfort had time to sound sirens and get people to
Yep.
evacuate, and because they had the advantage of all of the history of what had happened upstream
Exactly.
from them. So yeah, sirens are it's always a battle with sirens, but it's good to hear. It's horrible that it takes something like this, but you got to
Yeah.
look for the good and do something good out, get something good out of it. So that's certainly good
Yeah.
to hear.
Yeah, it's actually mandated. So it's listed in SB 3, which is the Senate bill that requires the sirens. And in the flood warning guide, outreach and education is required. However, there's not a dollar amount put on it, and it's not highly detailed. So I'm really hopeful that moving forward, they'll realize that in addition to the hardware costs, they've got to invest in their people. And they've got to put money toward really trying to understand how we help people understand how to get prepared for these and then how to act when they happen.
Yeah, Dr. Stevens, in Tulsa, the flood that Dr. Gorley
Yep.
mentioned back in '84, I believe they installed at the time a state-of-the-art outdoor warning siren system, and they do tones for higher end flash flood, and it's a British siren thing, but they experimented briefly with talking over them too. And you are 100% right. And the most effective thing that does is get every dog in the neighborhood going absolutely bananas when you start talking over those things.
Yes, it is. And, in theory, on a quiet day, if you're facing exactly in the one direction, yep, you might hear it perfectly. But I'll tell you that the number one comment that people make, and we've interviewed over 45 people now as part of our study, the first comment people make is they talk about the sounds, what they heard, train, they thought it was a train. They thought it was so loud. It was so ferocious. They talk about sounds, smells, like you're totally inundated. All your senses are being activated when you're going through these kind of really serious events. Kind of like a tornado. I grew up in Tornado
Right.
Alley myself. So yeah.
What's remarkable to me is what you're describing is so much of what we hear too when we talk to tornado survivors. And I
Yes.
think there's something about the hyper local, acute, very, very catastrophic event that it's hard to warn for in a way that really resonates with people. And especially when they have those experiences that tell them it won't be them until it actually is. This is a really tough challenge from a sort of warning, alerting, decision science perspective. And I'm wondering if we can bridge some of the insight that JJ was offering with, it might be wandering into conjecture a little bit from where you took your interviews, but what if? What if there had been a system that had provided information 5 to 7 hours ahead that gave like a 50% likelihood that this basin, I mean, that amount of water, and what you showed, JJ, also looked remarkably sort of conveyed some of the rate of water rise that was going to go on, that it was going to be one of these, like, it's not just 50% chance of it getting slowly up to the moderate stage. It was going to be in the course of a very short period. And I would think that that might, really trigger something in public safety officials if they are before they're going to bed, because we know that in this event there were some folks who were caught asleep, that weren't then able to keep that chain going of awareness building and preparing. And what it might be, again, conjecture land, but when you hear that, what do you think could have been, for this event? And maybe I know you said that the event that just happened was a little bit different in character, but
Mhm.
maybe it shows us the art of the possible.
Oh, absolutely. And I definitely think the fact that two events happened within a year of each other made a tremendous difference because people were on heightened alert and they knew it was possible. The irony with that is that I've done a few interviews since that time, and I'm still seeing some people saying things like, I still got caught off guard because I didn't think it was possible where I was because the river hit somewhere differently last year. So I think we have a lot of work in talking about what is possible and to help people imagine what is possible instead of getting them anchored in what has happened.
Well, and that brings me, I think, maybe JJ, this is a question for you. I really feel like, well, maybe that part of this is we need to get to the ability to be that hyperlocal, that specific in these forecasts. JJ, do you think we are close to being able to say something like this particular watershed is likely to experience catastrophic flooding in the next 6 hours that could speak to some level of that disconnect that we're seeing in the real world?
Yeah, so I mean, getting the information for the hydrologic model is pretty easy. I mean, we have very detailed data sets and digital elevation model down to 10 meter, 3 meters, something, crazy high resolution. But I mean, the key drivers, you got to get the rainfall right. I mean, that is absolutely essential in the whole forecast chain. And that's really the linchpin, that's where the focus really needs to be. And we saw a great example where things worked pretty well, very well. Is it going to be like that for every event? I highly doubt it. And or can we come up with, even this conversation I'm having with you folks now is really enlightening, and maybe we should have been speaking more down the forecast chain, because I can envision some products that we could even develop that's a rate of rise and things like that, which would be a simpler gridded product that could go to a forecaster, but it could show the severity and the quickness at which it's coming. And I think you probably would have seen a pretty big difference between, if you're looking at the two different events. You could say, well, we're going to have a large volume of water, but that's a much different story whenever it's rising very quickly and catching people off guard. So those are some valuable things that we can learn right now as we move into this project and potentially have some even more, added value to our products.
Yeah, I think that's great because that's something that people who live along the river, they do know the difference between like a rate of rise and rainfall, and they actually know a whole lot more than what people from the outside think they know. I've learned a lot. They've educated me. They're quite expert on their river. It is expert with history, but it's still, they know they would be capable of understanding that kind of information And right now, something like the FEMA floodplain maps, they haven't been mapped in that area for a long time. And so a lot of people don't know that they have that they're on probably an area that should be on a floodplain. And so giving them some more river kind of terminology, that might be a great way to go.
Yeah, we're talking about the bills in Texas, and certainly I think that set the stage for other states. I know the state of Oklahoma has passed several bills, probably modeled very closely after some of those in Texas, mandating safety plans for camps and alerting systems, and not exactly the same bills, but so, and I don't know about other states, but I'm sure that's happening as well. And it's been really interesting this summer how many more calls we're getting at our office from little tiny camps, just church camps that probably don't have any real threat of flooding in a really significant way. There's a lot of sensitivity to that, not just in Texas, but everywhere. I mean, how could there not be with this horrible catastrophe that happened? But it's interesting how it's spreading in good ways, mostly, I think. I mean, it's good that the awareness is there. It's sad we have to get there like this, but it is interesting.
Yeah. So there's a National Camp Association that some camps are a part of, and they have done a really great job of trying to raise awareness around the fact that there are some base plans out there that they can work off of. I've gotten to interview some camps that I tell you I would stay there in a heartbeat because they have fantastic emergency action plans. They totally know what they're going to do under all circumstances. Others not. And so there's a lot of variation that we see, and a lot more support, I think, for the camps that want to get that level. And some of it is the people who are sending their kids to camp, or the adults who are going to the camp. They're asking these questions now. And so that's going to drive some of those changes as well.
Yeah, I believe we saw a camp outside of, it was in Southwest Missouri, I think, that had catastrophic flooding this summer, and it was helicoptered out, but it was evacuated. They did succeed. It's I'm sure that was one of the camps. It sounded like they had a big plan. They executed it. Wonderful success stories are possible. So,
Yes.
yeah, go ahead, Jen.
So now I just had a quick question for Carrie. When you were talking to folks and survivors, did you
Mhm.
find that the ability to share with to help with some healing, and also, do you feel like they were open to having a change of thought? You know, of yes, they've got the history and all that, but that they were like with this event, and then just talking through things with you, that they were willing to maybe look at things differently.
Oh, absolutely. I actually started as soon as the flooding happened this year. I called all my research assistants and said, screenshot everything you can off of social media platforms, because I saw a drastic change in how they communicated publicly through social media this year. Um, they have learned a lot, and they are open to learning a lot. And I think that they're they're being super careful about what they're willing to say. And I work under an IRB protocol, so I'm super careful about the confidentiality of people I'm talking to. But I will tell you that many of them are doing great things. But unfortunately, the only thing that gets publicized are the negative. And I wish some of these best practices would come out. I talked to an RV park, and I'm really hoping that in the next phase of this project, that I'm able to get this RV park to share their emergency action plan with other RV parks, because small businesses want to learn from other small businesses. And if we can activate these networks of things that are great that are being done, that is the power of making real change happen.
Let me hop in real quick. Speaking of the RV park thing, hold on.
Yeah.
I'm in a very unique situation now. I am in a camper van.
Yes.
So I'm traveling, and
Yeah.
I've only been in this thing for 2 weeks, and I'm now in a very unique situation as a meteorologist traveling and staying at RV parks and campgrounds, and I'm
Mhm.
having conversations. I would love to connect with you because
Oh,
I think it would be I have an opportunity to speak to folks and share with them, hey, what is your plan? Do you,
yes.
just like what I just witnessed when I drove into Fort Pickens, but go, what is your protocol for severe weather, for flooding, for tornadoes, for ice, whatever? What is it? And I would love to be able to maybe find a plan for me just to have because I have a big mouth. How can I just share the narrow plan, narrow more plan of helping people at the campgrounds and the RV parks? So,
Mhm.
and she said she would drop off possibly, and she did. I don't think I scared her off though, but so anyway, that's what I'm thinking, Kim. And I've talked to the folks from Weather Call actually have a campground plan, and I'd love to get them on sometime to talk about it. And Carrie, I know I didn't scare you off because you're traveling and you're here, you're back, but there
I'm
are a
here
lot of
too.
things. Yeah, there are certainly some things that we can be doing, but I want to have a protocol of
Yeah.
what to share and who to direct them to and the best tools that they need to be able to have the best plan in place where we don't
Yeah.
get the, oh, you just have to fend for yourself. That's not the right answer.
No, it's not. And I think that in the past, from what I can tell, they're a lot more disjointed in terms of an organizing structure than the camps are. The camps have some national associations, and the RV parks in Texas are exempted. They can actually be on floodplains in most places, not all. Some local ordinances ban them from them, but many of them are on floodplains. And I actually 5 days before the flood this year took photos of an RV park, and the road may flood signs on either side of the two different ways you can evacuate. Both of them have road may flood signs on them. And I was talking through and I recorded a video and said, I just don't know how people would actually get out in a flood because this road, it looks like, could flood. Y'all, 5 days later, that road flooded. And I was beside myself I had been right there on Goat Creek Road. If you look it up, it's exactly the area that flooded. And so I think there are ways that they would be very open. The challenge that we all need to think about is they're also business people. And so we want to make sure that the tools that we give them resonate with how they need to be able to communicate to their customers. And so I think this is on our to-do list, and I'm very hopeful that my team has received preliminary approval that we're going to get some more funding to do this study, and this will be included as part of it, is trying to help come up with some protocols for RV parks. So let's keep in touch because I
Yeah,
do
please.
think they would be open minded as long as we give them tools in ways that they feel like don't harm their business.
Exactly. Yeah, we will talk.
Yeah,
I'm very
great.
passionate about this because now I am an RVer and I do get nervous myself and I watch the radar, but I'm watching what Span was throwing at me from Mobile going, "Oh crap. What am I going to do?" And luckily it weakened, but there is one of those you're going to get flooded signs when you're driving down the long haul to Fort Pickens campground. And I really didn't want to get stuck here, but also where would I go if I didn't want to sit in this van with 60 to 70 mile per hour winds blowing through, or a tornado warning comes out. I needed to find my right spot, and I was looking at all my neighbors. They're all my neighbors now, and I want to talk to them and make sure that they know because they see I have my logo for Tornado Talk on the van, but maybe I need some kind of extra and some kind of RV ambassador or something. I don't know. I'm gonna shut up. Carrie, we're gonna talk more.
Oh, let's talk because I think it's
Yeah.
great. And I don't think, even though you're a meteorologist, I don't think that it is a unique thing for those of us who study in this space. I think that a lot of people would be very interested in this kind of information, but a couple of the keys are needs to be just in time information, because giving it to people too far ahead of time, it's not resonating as being salient for them. And so an opportunity for us to do some very systematic research and some studies to try to figure out what's the right timing, what's the right format, and how we can get safety information in the hands of people that need it, that have historically been completely left out of the conversation, such as people who are temporarily in an area. Visitors are at risk.
Yeah.
Carrie, Troy here.
Yeah.
I think the thing that surprised me the most in 2025 when all this happened, and I realize things have changed, but we hear tonight that apparently in Fort Pickens it hadn't changed that much, is that in the litigious world that we live in, up until 2025, I was depressed at the fact that it seemed like places where we trusted our children to be gone and to pay a few $1,000s a week to put our children in these places did not have even the semblance hardly of a plan.
Yeah.
How in the hell did we ever get, and we're not, and let's not fool ourselves. Things have gotten better there. And I think, and we can go back to what you and Kim talk about with how long a memory we have for events. This will wear off if we don't get another event. But I guess, where did we ever get in this shape where these camps would have thought they didn't need a plan to protect lives?
I'm right there with you. I literally have sent my kids to camp. I've gone to camp, and I've rethought my own decision making as part of this as well. I am amazed at how many people don't realize the value of systematic emergency action type planning. They just don't realize how good it is. And y'all, I have an incredible story to share. I happened to one of the RV parks I interviewed 5 days before this year's flood, and they told me, they said, I asked the question as part of my interview protocol, do you have any emergency action plans? And the person said, no, I don't. I know I should. I'm former military. I do know these things are valuable. And then I immediately backed off as a researcher and I said, hey, I hear that a lot. And I went on with my protocol. They got hit again this year. And so I let a week go by and I called them up and I said, I'm just checking on you. I'm worried. And the person said, you're not going to believe this, but after you interviewed me, I sat down and wrote out a plan. And do you know, this year we were back up and operating in 2 days, and we never would have been able to do it if I hadn't had a plan together. And that's when I said, you want to join me in a study and let's see if we can't codify this and share it with other people, because you see the value of a plan now. And I think that's the key. People, and by the way, y'all, the other thing that I've uncovered is that a whole lot of homes for older adults, and by the way, that's the growing population these days, it's where our population growth is, the vast majority of those facilities also do not have plans.
Yep.
So I'm calling these groups caretaking organizations, but these organizations that are responsible for others, we're going to need to try to help them see the value of these plans.
Very well said. And thank you, Carrie. And by the way, JJ, thank you for what you've done. And I know you're not in charge of this, JJ. My concern with a lot of what you talked about is the speed of which government operates. You tell me 2 years, I'm thinking 10 years. And it's just the way I am. And I have my problems with the Weather Service right now, just on some of the way some things have been handled that aren't related to this. But I appreciate JJ, your stuff and Carrie's stuff, simply amazing tonight. Thank you for what you've done.
Thanks for the opportunity. I really appreciate it. Looking
Yeah.
forward to getting moving on the project. And yeah, this is something I've kind of had in my mind back from the very earliest days with the Warn Forecast system. Is like, we got to go after flash floods. We have to. And so I'll be going at it 100%, and I'm trying to clear off all of my paper reviews and all that kind of stuff. And interestingly, I just probably shouldn't say, but I've handled a paper that dealt with looking at age as a fatality circumstance, and they were looking at how the elderly are statistically becoming more frequently victims now, and it's because of those issues that you mentioned, and having more of them, and lack of mobility, and things like that. So they can get caught up in kind of the lesser flood, not the real big flash floods, but the slow risers. You just can't move that many people. So really intriguing that I fully support everyone having these kind of emergency operation plans and things in mind, just like you do, or you should do in your house. If with the fire, the same thing. We do that practice every once in a while.
Well, I got to tell you, Carrie, for someone who recently, let's see how I can put this, for someone who recently invested on some devices to help me hear better, I'm amazed by what I'm sitting here when you said that a few minutes ago. If you can't hear any of this, what different, good grief. And I've never thought about that. So thank you for that input as well.
I'm glad to hear that. I do. I feel like every time I do a field visit, and I've done a lot of field work in the last year, and I'm continuing to do a lot, because I find that a lot of these things I might get from a formal interview, but I also get a lot from just casual conversations with people. And I try to document as much of this as I can, because I'm learning a ton of things that I would have never imagined. And that one was probably one of the more eye-opening situations, because I've looked at the growing number of older adults in the US, and it's the fastest growing demographic. And we're going to have a lot of this to deal with moving forward. And we're just not talking about it at the level that I think we should.
Well, on that note, Carrie, I'm wondering if we can weave in something that's not necessarily about this particular event, but some other vein of research you've done has been on flood messaging and its efficacy. And one of our tried and true, well, not tried and true, but one of our old staid flood messages is the turn around, don't drown. You have looked at this as a messaging tool for helping to inform the decisions people make. What have you found about it? And, what have you found wanting about the message, turn around, don't drown?
Yeah. So first of all, it works. People who say that they've seen signs to turn around, some of them say they've turned around. However, the demographic that's most likely to die driving through floodwaters are 18 to 20 to 30-year-old, predominantly males, but also females. Whenever I show them the sign, turn around, don't drown, they laugh at me and they go, I'm not going to die. I've got a big truck. Come on. It's a challenge. I can go through that water. The number of times people tell me that is pretty shocking. And so what I did is I worked on a project for the Texas Water Development Board, and we iterated around, well, what kind of message might resonate with this younger demographic? And so I went in and I said, okay, you don't have a house yet, so you don't have a mortgage. So all that we talk about with flooding and homes, that's not going to work. What's your most expensive possession? And everyone in the room said, that truck. Their cars, their vehicles are their most prized possession. So I worked with a graphic designer and I said, sketch me up some ideas here and let's go back in and run a few more focus groups. And so I showed young adults a message, keep your car high and dry. And it works pretty well because immediately what they say is they say, oh, yeah, I don't want to hurt my car. Insurance is so high. Yeah, I don't want my premiums to go up. Yeah, I might turn around because I don't want to hurt my car. And so if we think about the psychology of young adults, and some of us for our whole lives feel invincible, but they know their car's not invincible. And so I think we have some great opportunities to add more messaging that's targeted to different specific age groups and demographics that increase the likelihood that they're going to pay attention to the messages. And the other related message that my team has stumbled upon consistently is low water crossing. A lot of people don't understand that. One of my studies, approximately a third of the people that I would show the low water crossing sign to would say, oh, yeah, that means that only a low amount of water crosses in that area, so it's completely safe to drive through. And the first few times people said that, I was like, okay, low water crossing. And then if you add the complication there of people who speak different languages where adverbs are in a different order, almost always they go to that kind of a interpretation of that message. And so what we've seen happen recently in a lot of different places in Texas, and I've seen it in other places in the US, is they're installing high water alert systems. Well, what is it? Is it a low water alert or a high water alert? I think we need some consistency around our messaging because as I drive through back to the floods, and I have many, many pictures of what a true low water crossing is. And that water, even when it's not over the road, is within 3 inches of the road. That is that's scary for me now to drive across. But people do not think the word low water crossing means it's dangerous. So we have some work to do, I think.
All right, so it's
I think
8:35. We have to take a break here in just a second. And by the way, JJ, thank you. I feel like I've been to an AMS workshop here tonight. That was outstanding. That presentation was too stinking good. And Carrie, thank you. And let me just say one thing really quickly before we take a quick break. I'm a tornado guy. Hydro is hard. Hydro is hard. This ain't easy. It affects different people in different ways within a short distance. But in my tornado world, one of the keys to being successful, it's just people getting the warning. So one quick question for both of you, I guess. How many people in the floodplain in Texas has one of these? Do we know? Troy, what do you think? And you're muted, Troy.
I have no idea, but our problem is, and this is a whole nother topic for a whole nother night, is that, and James, you mentioned it, but there is an overwarning problem in this country. And what's happened is people are turning these things off.
Yeah.
I won't say where it is, but I've even had emergency managers tell me sometimes this thing is going off so much that we end up turning it off. And it's at that point that I kind of shake my head because I feel like all is lost at that point. And again, I think Midland and the other weather radio, I think we've got to bring that technology beyond the 1980s. We've got to get that technology also a little more, but I have no idea, James. It's a great question, but I don't think there's anyone on this call that can answer that.
I would assume nobody at the camps had one of these things. Nobody, right?
I think some of the camps did, but I'm not aware of the counts.
And for those listening, we're showing a NOAA weather radio. And to me, that's still our baseline. And I have learned that many of our people here have turned off WEA. They They've gone into settings, they've gone into emergency alerts and turned them off because they don't want to receive an Amber Alert. What's the matter with you? I mean, what is the matter with you? So there's a
Well,
child missing, and you're saying
Yeah.
you don't want to help.
Well, they actually,
That's
James,
nonsense.
now on these phones and everything, they actually separate that Amber Alert out from the emergency alerts. That is something where they separate it out, which is good. But you could say the same thing for the NOAA weather radio, James, because if you don't have that especially set, and by the way, this involves setting a radio 1980s, 90s technology to not include the Amber Alert. And then what do people mainly do? Well, I'll just turn the alert off altogether. And there you go. You've defeated the purpose at that point.
Yes.
And I do agree that overwarning is a problem, and that's again a topic for a different show. But I hear this constantly. I hear these warnings all the time: flash flood warning, 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 and nothing ever happens.
Yeah.
And I just, Carrie, is that a problem? You're a social scientist. You tell us.
Yeah, it is a problem. People become habituated to them. People don't want to be interrupted. I have some very interesting things that have been sent to me from actions that have well, and I have a couple of slides that I won't get into a lot of detail, but essentially the mobile phone companies, both Apple and Android, have now added, y'all may not be aware of this, but they are actually amplifying iPause alerts. But I don't know who they told they were doing that to, because it sure didn't get to everybody locally, especially some local National Weather Service folks and not emergency managers either. So in theory, that's a great idea. However, what happens whenever people get awakened not once, not twice, but 3 times with what looks like the same alert that came from the same source, but it actually didn't? It's a real problem because they get angry at the source, the National Weather Service, yet the National Weather Service didn't send all those alerts.
Exactly.
And so we have a lot going on right now in the alerting world that needs to be resolved.
Yeah, and we'll have to stop here, but it's been a great discussion. But if you can bear with us for a few more minutes, JJ and Carrie, we're going to take a very quick break. We're going to hear from Tony Rice and his astronomy report. Got a big lunar eclipse Thursday night. We've got Jen and This Week in Tornado History. Hit a couple of emails. We'll do picks of the week and more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
This Thursday night into Friday morning, August 27th and 28th, the moon will be partially eclipsed by the Earth. But partial, that undersells it. At maximum eclipse, about 96% of the moon's disk will be inside the Earth's darkest shadow, the umbra. That leaves just a thin sliver of moon, not reflecting light filtered through the Earth's atmosphere. And while it won't take on that striking deep orange reddish color that we see during a total lunar eclipse, the color will still be present over the rest of the moon as only those longer red light waves punch their way through our atmosphere. Think of it this way: not unlike sunsets, lunar eclipses are red for the same reason the sky is blue. For most of North America, this is a nighttime event. The partial phase begins about 10:34 p.m. Eastern on Thursday evening. Maximum eclipse comes at 12:13 a.m. Eastern, 11:13 p.m. Central, 10:13 Mountain, 9:13 Pacific. The partial phase ends roughly 3 hours and 20 minutes after it all begins. My favorite time comes about 45 minutes before and after maximum eclipse, when about half the moon is in the umbra. That's when it really looks like an eclipse. Also, that's when you can really make out the curvature of the umbra. And that's exactly what deep thinkers like Aristotle and ancient Greece were looking at when they came to the conclusion that Earth is not flat, it is a sphere. The farther west you are, the earlier in the evening you will see maximum eclipse and the higher in the sky. Here on the East Coast, the moon will be well up in the southern sky around midnight. On the West Coast, the eclipse reaches maximum not long after sunset, so finding an unobstructed view towards the southeast will be important. You won't need any special eye protection for a lunar eclipse. The moon just needs to be visible, so clouds are the primary forecast concern here. It's August, so afternoon thunderstorms are generally in the forecast, but as the heat of the day subsides, so can cloud cover. At least that's what I'm hoping for. The next lunar eclipse is of the far less impressive penumbral variety on February 20th, 2027. There's a very shallow partial lunar eclipse on January 12th, 2028, barely 2% though. So the next good one will be a total lunar eclipse on June 26th, 2029, which will be particularly well placed for the Eastern and Central time zones. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, an unexpected tornado outbreak occurred on August 24th, 2016. 22 tornadoes were recorded in portions of Ohio and Indiana. 2 tornadoes occurred in Ontario, Canada. This event is in the top 10 for the largest number of tornadoes in a single August day across the U.S. since records began in 1950. One of the strongest tornadoes of the day hit at 3:20 p.m. Eastern Time in Howard County, Indiana. It hit the Kokomo area. The tornado tracked over 8.5 miles with maximum winds estimated at 152 miles per hour. The Howard Haven Residential Center at 3600 West Boulevard received extensive damage. The director of the center, Jennifer Brower, protected one of the residents from flying glass by shielding her with her own body. They both received just minor injuries. In the Markland Mall area, a Starbucks was flattened. Shift supervisor Angel Ramos was hailed a hero for calmly asking the patrons to take shelter in the bathrooms. Everyone survived. Per the National Weather Service, a total of 1,000 homes sustained some degree of damage. As the residents of Kokomo were analyzing the damage around them, little did they know that 4 more tornadoes were to occur across parts of Howard County several hours after this devastating blow. It was a tremendously unnerving time for the community. These additional tornadoes steered clear of Kokomo with less damage. The August 24th, 2016 tornado brought back memories to a twister that hit practically this same area only 3 years before. On November 17th, 2013, an EF2 damaged well-built homes and other buildings on the south side of Kokomo. Get hooked on tornado history with us by going to our website, tornadotalk.com.
Well, it's time to dig into the email inbox, and maybe there's something in there to read this week.
I've got our email of the week coming in from Lars from Europe, kind of giving us a little overview of how it's been lately. Hi, WeatherBrains team. Thought I'd give you a little update on the intense summer weather we've been having here after many weeks of hot and extremely dry weather in Central and Western Europe. Several wildfires occurred in the UK, Belgium, far western Germany, something that is more common around the Mediterranean. While most of those wildfires only affected relatively small areas, the largest fire devastated a large part of the High Fens area, a vast, usually cool and wet moorland near the German-Belgian border. About 7,500 acres of moorland and nearby forests were destroyed in the largest such fire in the history of Belgium. The 1911 fire affected a similar size. While firefighters are still trying to contain the remnants of the moorland fire, a sudden shift to a much more dynamic weather pattern last Wednesday provided several severe thunderstorms across a corridor from southern Belgium, one tornadic circulation passing about 8 miles from the fires to eastern Germany. Supercells and Boeing segments produced at least 4 confirmed tornadoes and fairly widespread straight-line wind damage, and 2 people were killed. Several others were injured. And then just today, south of France saw a significant tornado during a severe weather outbreak. So we love hearing from our European folks. Thank you for that great email giving us an overview of all that's been going on here. I'm going to open up our what's going on here in the next 3 days. And now John Gordon is not here, and so he's slacker. And he's not here, so I'm going to have to talk through the slide. August 31st, next week, we're going to do some hydroplaning talk, and we're also going to get an update from Alan on the AMS. And then on September 8th, that's right after Labor Day, we've got CBS News meteorologist Rob Marciano, author Willie Dry, and then the weather guys join us, Dr. Stephen Ackerman and Jonathan Martin on September 14th. So a lot of fun things happening, and we're going to have some fun stuff going on. Email at weatherbrains.com if you have show suggestions, updates on your weather, and questions for us. We'd love to hear it.
Email at weatherbrains.com. That's an easy one to remember. All right, let's morph right into picks of the week. So Carrie and JJ, we're going to put you at the end here to give you time to think about it. Everybody's going to share something that is cool, weather-related, interesting. This can be a data source, website, app, anything remotely related to weather. And we're getting close to the top of the hour. So, James A., before you have to do the 9 o'clock news, let's get your pick of the week. Go.
All right, mine is a sequence of video and even a radar pic of the supercells in France that produced the tornado. And behind Dr. Gorley, a gusty from the great Don Woods, longtime meteorologist at KTOL in Tulsa. And there's one with Gusty jumping into his Frady hole that he watercolored. So very cool. That's great to see.
Wow. Outstanding. All right, let's go to Rick Smith for your pick of the week, sir.
I can guarantee we've shared this pic before, but the Iowa Environmental Mesonet, they've got a data plotter page, and my pick of the week is specifically the severe weather page. You could get lost for hours on there looking at all the different statistics and ways to slice and dice, warnings, watches, mesoscale discussions. Pick your house and it'll tell you how many tornado warnings you've been in. It's endless fun, so that's my pick.
It sounds good. All these picks, by the way, will be up on the website, weatherbrains.com. Okay, Kim, I know you've got a good pick of the week. Go.
Yeah, so I realized I had for my pick of the week something that JJ may want. I picked your team's dual papers. You may want to have that as your pick of the week. Totally fair game. So I'm going to choose something slightly different. There is an ongoing weather catastrophe that's an aftershock of something that happened almost 2 weeks ago now in northern Indiana, where I'm from, Gary, Indiana. Much of that area has been without power now for almost 2 full weeks. And it's getting it to the point where, it's long been past a point of concern. But finally, in the eyes of many of us, the governor is actually speaking about this, and is today there was news that he was looking to possibly investigate the power authority over the lack of ability to restore power to that area. So more to come on that, but be thinking of the people of Gary.
Yeah, that's horrible. I've seen a lot of traffic on that, but that's a really bad situation. So anyway, thank you, Jen, or Kim. Jen, now let's go to you for your pick of the week. Go. And you are muted, ma'am. We cannot hear. Yes. Yeah.
So sorry about that. No, John Gordon wanted me to give his pick of the week, so I'm going to continue to have to pull slacker again. Here's his pick of the week, but it's actually Michael Vinsky, who is amazing monsoon storm chaser, and a great picture of a moonbow in Arizona. Great pick of the week. My pick of the week is actually the link to get you over to the University of West Florida archives, where I spent some time today. I looked at 17 tornado events today, 43 people I was looking at who have passed away in tornadoes. And the first event was 1877. The last event was 2022. There are 2 names I could not find. I found some partial names, but there were 2. So I found at least 41 people today with the research, and they were a great help pulling out newspapers and books and what have you. So if you're doing some research and you want to, dive into your history of your family or weather history, go to the University of West Florida in Pensacola.
Again, all these links will be up on weatherbrains.com. Mine is a paper released today from our friends at INSEP, the Climate Prediction Center, CPC, which is a part of INSEP, the current ENSO phase, the Super El Nino update. And that was released today. And there'll be a link to that up on weatherbrains.com. Troy Kimmel, what you got? Go.
This will tie back, I think, to Kim's pick of the week nicely. And I think we've all used this before, and I'm not sure that we had this pick of the week, but poweroutage.us. And I'll mention this because Jay Schaefer, Dr. Jay Schaefer, who I've had served on a committee with me in the AMS, he's now involved with that organization and heavily involved, and got an email from him. And I think for even some of their business users now, they're doing forecast of power outages over the next couple of days. This is something they're doing now for the paid users. And I think it's an amazing job, what they've done there, and especially poweroutage.us, a great website. I highly recommend it if you haven't seen it.
I use it often. Great pick. Okay, JJ, thanks for staying with us for a couple hours. It's been a long night for you, but give us a pick of the week. I know it's going to be good.
You put me on the spot, but I think I came up with them. So with one, we've got our second, like pretty sizable city that's now faced evacuation orders due to wildfire. Spokane was first, and so while I'm on the topic, I think when the Spokane one was occurring, I went to the National Weather Service page to get an update there. And then they actually advertised this app that everyone probably knows about. It's called Watch Duty. And I installed it immediately. And man, what an incredible piece of work that is. I was blown away by how effective it is with evacuation routes, shelters where they are, specifically who's impacted. Updates are coming one by one on their pictures. It's fantastic. So that's what I'm going to go with.
That is a great pick. I'm glad you picked that because that is an amazing app. So again, we'll put the link up on the show notes. Okay, Carrie, your turn. Give us something good. I know it's going to be good.
Well, this is something y'all probably don't know about, but since we talked about so much the flooding in Texas, there is a new hazard institute, and part of what they'll be doing is talking about the importance of emergency action plans. And so the acronym is TIHRR. So the Institute for Hazardous Risk and Readiness. It's at Schreiner University, which is in Kerrville, and they are just standing up this institute, and I think it will really do some wonders for rural communities and for talk about how we put together flood emergency action plans.
Excellent. And again, we'll put this up on weatherbrains.com. So Carrie and JJ, anything else we need to promote? Anything before we wrap it up? The weather world is listening.
Yeah, so wildfires are problematic by themselves, but they're also big flood producers.
Yeah.
So I think we're going to hear about that, and coming whenever the rainy season impacts these areas. You're going to see a lot of flooding and debris flows and things. So don't go to sleep whenever the fire's out. You've still got a problem.
Yeah. Well, I guess what I will just say is that one of the things I think that's so great about the weather community is that we're all hyper aware of the importance of people and trying to understand kind of the decisions that people make around weather. So I just want to thank you all for having social science be such an integrated part of these types of conversations, because I'm learning a ton and hopefully got to share some interesting and helpful things with you as well.
Well, social science has changed everything I do in terms of messaging, the thought process, communication, the integration of physical science and social science. This interdisciplinary approach has been just remarkable. So thanks, Carrie, and thanks, JJ. And for those that are listening, thank you. If you're new here, we typically record on Monday nights at 8 o'clock Eastern, 7 o'clock Central. But most of you listen. But if you want to watch, you can do that. YouTube.com/weatherbrains. And remember to get in touch with us. The email address, it is email@weatherbrains.com. If you got a question about what we talked about tonight, maybe a topic suggestion, a guest suggestion, let's hear from you. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless. Thanks, everybody. Great
Thank
show.
you, Carrie.
Thanks,
JJ.
Max.